These 6 different types of bubbles are the seeds for the 6 subuniverses. They will grow to like our subuniverse to a radius of 13.7 billion light-years. The diameter of space of our universe can even expand to 92 billion light-years due to inflation. The volume of our universe can also increase or shrink due to the ratio of incoming and outgoing particles. Are the number of subuniverses restricted to 6? Probably not. It could be that there are more than 6 subuniverses. We may never find out. The reason we think it is most likely that there are 6 subuniverses is that there is 5 times more gravitational pull on the galaxies. This additional gravitational attraction is referred to as dark matter. The matter that creates this additional attraction is invisible to us. It is pure speculation that we came up with the assumption that there are a total of 6 subuniverses, and that we occupy one of them and that one is the only one visible to us. The 2 are elements that will appear initially right after the quantum inversion warp are the space-time and the matter-energy. How did these 2 elements appear? They are part of the random quantum fluctuation event process, and are reset through random evolutionary trial and error reject or select to the correct relations of the constants to each other. Element number 1 is space-time. If time increases, then space shrinks. Created out of nothing with random quantum fluctuation event, and can collapse back into nothingness again. Element number 2 is matter-energy. Energy is convertible into matter, and vice versa, and creates the forces. E = mc², Einstein. Forces are gravity, Higgs boson fields, and 3 other forces: electromagnetic, weak and strong nuclear force. At the edge of our universe is the outer edge spherical shell singularity horizon, just inside that entrance horizon into our cosmic microwave background. All 6 subuniverses have a common outer edge spherical shell singularity horizon and cosmic microwave background. The cosmic microwave background is time-sensitive. What we see today is the cosmic microwave background the way it looked 13.72 billion light-years ago. Now it has expanded to over 92 billion light-years from the location where we are now. On the other side of the outer edge spherical shell singularity horizon is COEM. What enters our universe through this horizon are the particles or sparticles, with the kinetic energy generated by falling into the black holes. In the subuniverses, this kinetic energy converts back into particles or sparticles, and form the galaxies. Let us quickly get an overview how our universe has divided up. 50% is a positive and the other 50% is a negative group, which are each subdivided into subuniverses. The positive group contains particles. The negative group contains particles. Our sub belongs to the positive group, and we are about 33.3% of that positive group, which is the same 16.7% of the entire universe. Our visible subuniverse consists of 3.58% free hydrogen, 0.45% stars, 0.27% neutrinos, 0.03% heavy elements. What we can see is about 4.3% of particles that are in our own subuniverse. The particles or sparticles of the other 5 remaining subuniverses are invisible to us, and are referred to as dark matter. The gravity of those superposed 5 subuniverses is still there, and leak through the black holes, and act as the missing gravity into our sub. This might be the answer how we have 5 times more gravity that holds our galaxies together. The dark energy has a totally different source. It is the kinetic energy from the particles or sparticles traveling at high speed from the outer edge spherical shell singularity horizon to the black holes. Currently that energy is about 3 times bigger than that of the dark matter.
Energy and matter distribution in the entire universe. We will have now a closer look at the proportion of energy and matter in our universe. Currently the entire universe consists of 72.4% energy and 27.6% matter. The visible portion of our sub-universe, as part of the entire universe. Our visible sub-universe is here shown as a blue pie section. This is the 4.33% of the visible particle content in our sub-universe. The other 95.67% is the dark energy of our own sub-universe plus the dark matter and dark energy of the other 5 sub-universes, that are all invisible to us. The 4.33% particle content of our entire visible sub-universe. This is the small 4.33% blue pie wedge shown now as a full pie with its particle content. Here is a breakdown of the particle distribution of the 4.33% visible pie section of our sub-universe. Free hydrogen and helium 3.58%. Stars 0.45%. Neutrinos 0.27%. Heavy elements 0.03%. The standard model of particle physics. We will give you now a quick overview of the new particles that can evolve from the original spun particles by the random quantum fluctuation events function. The 3 generations of matter ferments can be clearly recognized. These original phase-shifted particles behave similar like stem cells in biology, and can develop into any other of the standard model particles and the supersymmetry particles of physics, to form the sub-universes. Dark matter. We will discuss now a phenomenon observed concerning a discrepancy in the velocity stars rotate around their galaxies. Rotation curve of a typical spiral galaxy, predicted A and observed B. Dark matter can explain the velocity curve having a flat appearance, out to a large radius. Fritz Zwicky postulated in 1933 that, due to the high angular velocity of the galaxies, there was some serious mass missing in our visible universe. This missing mass neither emits nor scatters light, and was later referred to as dark matter. Calculations have shown that there is 5 times more dark matter than visible matter in our sub-universe. Dark matter can explain the velocity curve having a flat appearance, out to a large radius. The big question is, where is that elusive dark matter hiding? One suspicion is that the gravity-producing dark matter is hiding in the other 5 subuniverses. It is then leaking into our subuniverse through the black holes. Dark flow. Besides the dark matter, there is another dark phenomena, referred to as the dark flow. The difference in velocities predicted by Hubble's law and the actual measured velocity of galaxy clusters is referred to in astrophysical term as the dark flow. The dark flow indicated by the colored dots are clusters within one of 4 distance ranges, with redder colors indicating greater distance. Colored ellipses show the direction of bulk motion for the clusters of the corresponding color. Images of representative galaxy clusters in each distance slice are also shown. Image credit, A. Koshlinsky, NASA. Analysis of the 3-year WMAP data coherent 600 to 1000 km per second increased flow of clusters toward a 20-degree patch of sky between the constellations Centaurus and Vela was be observed. This could indicate that our galaxy is just a little bit off-center in the SIT space.
Let us review what we have learned so far. First, COEM, or collapsed emptiness, that existed everywhere. At COEM there is always an everywhere, since there is no space-time. Everything is located at one and the same point, since there is no space between the different objects.